Honey is an amazing superfood, but there are many qualities to this liquid gold that many people have never even heard of. Today we will be diving into the chemistry of honey and finding out just what all the buzz is about. I personally chose this topic because I'm a beekeeper here in southeastern Louisiana and have been for the past 10 years. It is an amazing job, and I hope this video presentation sheds some previously unknown light on the field of beekeeping and honey for you. Honey itself is derived from the nectar of various plants. This nectar, which varies from plant to plant, is a combination of sugars, proteins, and many other compounds. This is why honey is normally used as a sweetener, because it mostly is made up of natural sugars, most commonly sucrose. This sucrose is in many of the sweet treats that we eat, as it is generally found throughout kitchens as simple table sugar. For those of you who have shopped around for natural honey, you might have found that there are many different varieties of honey. For example, we have clover honey, manuka honey, sourwood honey, just to name a few. All of these variations are created by different nectars that the bees feed off of. Clover honey, for example, features nectar from bees that predominantly collect from clover flowers. Because of this, there are probably just as many varieties of honey as there are bees in a single hive. Once the bees gather the nectar, some magic occurs that turns this sweet liquid into honey. Now, I have to warn you, this magic isn't exactly pretty. When the worker bees collect the nectar, they store it in a separate stomach. We beekeepers inventively called it the honey stomach. In there, the nectar will mix with various enzymes to begin to break down the sucrose into simple sugars. Chemically, the sucrose is being broken into glucose and fructose. Once this bee makes the trip back to the hive, it will turn the solution over to one of the house bees. This process is done by regurgitation. That's right, the honey we eat can be seen as bee vomit. Just very delicious, sweet, and tasty bee vomit. In fact, the house bee who takes the solution will continue to regurgitate and re-drink the mixture until it is broken down to their liking. Once this process is complete, the bee will store the liquid in the honeycomb found in the hive. Because the solution is a majority water, the bees must evaporate for safekeeping of the honey. Honey at this state is very, very loose. It's not like the thick syrup we're used to. The house bees complete the drying by putting their wings to use. They will flap their wings in order to fan the honey until the moisture levels are around 17%. In fact, as beekeepers, we have to check the moisture content in our honey to ensure that the product does not ferment. To do this, we use a tool called a refractometer, which uses light and the speed at which it moves through the honey to determine the water content. It is because the water levels are so low that honey is one of the few foods that never actually spoils. In fact, they have discovered honey that was still consumable in Egyptian tombs that dated as far back to close to 3,000 years ago. Bacteria and fungi simply cannot grow in the limited amount of moisture in the product. While honey never goes bad, it does crystallize over time. This is due to the glucose, as it forms solid crystal-like structures as time goes on. This in no way damages the honey. In fact, the honey in its jar can simply be placed in warm water for a few minutes and the honey will return to its delicious syrupy form. I hope this gave you an overview into how chemistry is used to create one of the most common natural sweeteners. Some may call it bee vomit. I call it honey.